a couple of different sections. So we're going to be covering and revisiting the end of chapter 9 now in relation to the coordinate plane. And we've looked at this a couple times, more specifically last week when we studied how to graph an equivalent proportion. But we're just going to revisit this topic with a little bit more detail and involving numbers that, take a look at the bottom of 159, are not perfectly whole numbers. Some are decimal, some are fractional. So we're going to have to acknowledge their position on the entire coordinate plane, knowing what we know about decimals and fractions, and it looks like negative and positive integers at work. So I gave the kids here at school a moment to read 159, and I'm hoping you previewed that now that you saw it on the screen. This is 159 page, but what we're going to do first together is this bottom section of 159, acknowledging what quadrant those points exist in. We don't have to plot them today. We're just acknowledging where they exist in the coordinate plane. So take a look at the coordinate plane. I'm just going to zoom into it briefly here. Come on, little guy. Boop. That's a little better. If we zoom into the coordinate plane, what would this point right here be called? Right here. Oh, this point right here in the middle be called? What's that? The name of that point? Right here. Say it with me, everybody. Origin. Origin is the beginning of both the x and the y axis. The x and the y axis are nothing more than two number lines fixated perpendicular to each other. The x axis runs, if you had to tell me a word, one word that defines the directionality of the x axis, what one word would you say? Horizontally. Very good. The x axis runs horizontally. It's the independent axis. And then the y axis runs what? Vertically. Good. And so we begin our understanding of these two number lines by going in the positive direction and going up in a positive direction. We called this quadrant, quadrant 1, because both the x and the y values are positive. And then if you want to take maybe a colored tool or something and sort of put your pencil down here and then twist around counterclockwise, that will help you remember the direction you go to identify quadrant 1, 2, then 3, then 4. They go counterclockwise, beginning with the positive and then positive x and y values. In quadrant 2, notice how the x values are negative always because they go this direction, but the y values maintain positive values. When you travel to the third quadrant, what happens? Negative, negative. When you travel to the fourth quadrant, what happens? First, it's positive and then it's negative, right? It's positive going horizontally and then negative going vertically, going down. So we don't even care what numbers they are. We just care what value, positive or negative, they carry. So look at 159 now. I tried doing it on my laptop. Have you ever had your cursor disappear on your computer? Yeah. It's a pain in the butt, and then it's just all over the place. I can't figure out where to get it, how to return it to my page. It's just clicking on random things. So we're closing that for now. I'm looking at the bottom of 159. Let me zoom out a little bit more if I can. Come on. I'll get rid of that drawing. Just look at the bottom of 159, and we're going to just write Q1, Q2, Q3, Q4. where would a negative x and a negative y value exist? Which quadrant would that be in? Quadrant what? Quadrant 3. So please on the line here for number 1, just write Q3. Number 2, first the x value is negative and then the y value is positive. What quadrant is that? Quadrant 2. So please put Q2. Go around through 159, finish identifying what quadrant those points exist in. Go ahead. 1 through 10. All right, help me out. Number 3, what quadrant does that exist in? A little bit more clear, everybody. Quadrant 4. So just say Q4 for me, okay? Q4. Number 4, where does that exist? Q4. Number 5, where does that exist? Q3. Number 6. Q1. Number 7. Q4. Number 8. Q2. Number 9. Q4. Number 10. Q2. Q2. Good job. So just kind of previewing. We're not going to do it right this minute because we have a couple other things to review here together. But just previewing page 160, you're going to be in charge of this later. Not only are you going to have to identify what quadrant does that point exist in, but you're going to have to place it. You're going to plot it on this coordinate plane. Okay? I'd like to do a couple with you right now. Could you please use an alternative color besides a pencil? It's a little too hard to see. I want to give you instruction on how to plot the point and label it in a way I know that you know what point was put in that spot. So for A, point A, we're going to be labeling it at the location 1.5 on that X value and 3.25 on that Y value, right? So go to the origin and look at your scale. Go positive 1.5, which I can tell is halfway between 1 and 2 here. And then travel up vertically, it's positive Y value, all the way past 3 to where you would best estimate 3.25 to be. So I think it's right about there. Would you agree? Yeah. Okay. When you place that point, you have to label it with its name. Please put an A next to that point. Done. How about B? Where is B located? What quadrant? Quadrant 2, right? Because you're going to have a negative X value and then a positive Y value. So it should be right about there. Everyone labeled that one B. Getting the hang of this? This is similar to that Easter Bunny coordinate plane thing we did a while ago, but the numbers are a little more difficult because they're fractional or maybe decimal values. Sure, let's do one with the mixed number. Let's do C.
Wait, was number 1 Q2 or Q1?
This is quadrant 1. Are you talking about this one?
Oh, yeah.
Okay. C, let's look at C. What quadrant will this negative negative exist in? Negative negative is down here in Q3, right? So go to the origin, go -2 1/4, -2 1/4, and then descend all the way down to where 1 intersects it, that 1 line. And what should I label it? C. Label it C. Any questions about plotting points? Yes.
So like on the bullet, it says -0.75.
Uh-huh.
So would we just think of it kind of like 75 cents and see how we're to plot it?
If it helps you to relate it to money, to understand the value of that decimal, I'm not going to stop you, but knowing that 1 whole represents 1 whole dollar, I guess I can understand that. You're not going to see a spot on that labeling to put a 0.75. You have to gauge where it exists based on here's 0, here's 1, where would 0.75 exist? Yeah. So on the problem solving section, you're doing the opposite skill. You're looking at the coordinate plane that has points plotted on it and creating a coordinate point. So let's scroll down and take a look at that. You're going to do the rest on your own. Please pay attention to the section I'm focusing on so that you can get it all done accurately. Tanner's Camping, use the map of the campground to complete these exercises. So notice for number 11, the black diamonds represent the locations of the 4 restrooms on the campus, on this property. What are the coordinates of the restrooms? So coordinates mean you have to give me 4 ordered pairs, right? With an X value and a Y value. There's 4 of them with an X value and a Y value. What am I putting around my coordinates? Parentheses, right? So I'm just getting them ready. I'm going to have 4 coordinates. They're the directionality of these spots. All right, so I don't care which one we do first. How about we do the one that's in quadrant 1 first? Do you see it right here? Give me the X value that matches this coordinate spot right here. What's the X value that goes with it? 1. Good job. So we have to look at the X value first, which is 1. And then we have to look at the Y value that goes with it, which is 4. Okay, always X value first and then Y value. Good. Okay, let's do another one. I'm going to circle this one in purple. I'm in Q2 now. What is the X value of that black diamond, class? -4. And what's the Y value? 2. +2. Great. Okay, I'm going to Q3 here. X value? -2. Y value? -4. You getting the hang of this? Last one. X value? 3. Y value? -4. Good. Don't forget those negative or positive integer markings. They help with the whole directionality, okay? The rest of that exercise list is very similar in nature. So I'll let you handle that on your own. Please flip now to 163. 163. We're going to preview tomorrow's work so that you can get to work on it when you're ready, either later today or you can go after that tomorrow. We don't have another Zoom this week. So that's going to be on 163. Let's take a break and go preview that section. So 163 has some more coordinate plane activity. This time we're finding the distance between points. And oftentimes you can simply put your pencil at one point and count the units until you get to the second point. There's other ways to do it. You can combine the absolute values of those 2 points with each other and get a total amount. Counting the distance between the points is easy when your coordinate plane is rated by 1, 2, 3, 4, 5. It's easy when the scale matches whole numbers. But what if the scale matched 5, 10, 15, 20? Their distance would have to complement that, right? So if we look down the page a little bit, this first one, notice how the scale goes by 1, 2, 3, 4. It's very simple, right? Just by ones. So it's easy for us to count between units just counting by ones. 2, 3, 4, 5, 6, 7. So the distance between point A and B is 7 units, right? But what if these weren't by ones? Let's just pretend for a minute they were by fives, okay? So if the scale was written by fives, then how do I have to count between the units? How do I have to count? I have to count by fives, right? So I'm still making 7 hops, but it's 7 hops of 5, not 7 hops of 1. So I would count by fives, 5, 10, 15, 20, 25, 30, 35. So the distance, if the scale were by fives, then the distance would be 35 units between A and B. Does that make sense? So caution about the way that the scale is demonstrated on your paper. So what if you don't have a drawing at all? As you can see down here in the exercises, they don't give you a graph at all. You just have to look at the distance between the written points, the written coordinate points. So I'm going to try and identify what number would make these 2 points 6 units apart from each other. So if this 6 vertical units. So which position am I looking in for vertical movement? Am I looking in the X spot or the Y spot for vertical movement, class? I'm looking in the Y spot. So it's not this first number. I don't care what that is. I'm only looking at the second number. If I want this to change by 6 units, what could this new number be in that position there? What could that second number be? There's 2 options. What's one of them, Finn? It could be +6. What's the other option that it could still be 6 units away? Lucy, what do you think? -6. Good. So that value with the question mark could be +6 or it could be -6, right? So on our line here, guys, I want you to write both of the 2 possible missing coordinates. Could be 6 or it could be -6. Good? Let's do number 3 together. This time we're considering horizontal distance. So what axis pertains to horizontal distance? The x-axis. So highlight or circle or take a look at only the x values. Now think of going, since we're moving horizontally, think of sitting on -8 and moving either to the right or to the left 3. If I'm moving to the right or the left 3 units. Pretend you're kind of hopping forward 3 or hopping backward 3. Where could you land? What's one place, Parker, that you could land?
-5.
Parker said -5. So he's going more towards the positive direction. He's going 3 units in the positive direction and he'd land at -5. Good. Where's the other direction? Going more into the negatives. Where would you land? Go ahead. I can't see who that is. Alicia? Okay, Alicia, she's like halfway under the table there. Alicia, where would you land if you went more towards the negative direction? Negative 11, good. Paige, question or answer?
I was going to say negative 11.
Thank you. That would be right. So either way, does the y value change at all, class? No, there wasn't a change at all in the y value. Leave those alone. We're just wondering what could this question mark spot become if there was a change in distance of 3. Go ahead, do number 2 and 4 on your own right now. 2 and 4. All right, stop. Even if you're not done, stop. Number 2, vertical distance. What is changing, x or y value? Okay, y value. If it's changing by 5 units, give me 5 units that are either up or down from this measurement. Give me one. Give me one, Isaac. Give me one. He said negative 4.5. So if I were, and this might help you to look at a coordinate plane actually, if you were subtracting or going down 5 from negative 0.5, you would have to go a little bit farther than that. So what do you think? Exactly. So how about negative 5.5? You got it. So this missing value could be negative 5.5, or it could be, what do you think, Zoe?
4.5.
Positive 4.5, right? So having that decimal value involved does complicate it a little bit, but just think of it nudging forward or backwards, up or down. Think of that movement as gain or loss. Remember when we did integers? I think we were all online. This was around Thanksgiving time. Positive, negative integers and how they combine and relate to each other. All right, we're looking at number 4 on 163. Are you? Are we looking at number 4 on 163? Because that's the page I'm giving instruction on. And I want to make sure that everyone knows what we're doing here. Horizontal distance, what value is being altered here for horizontal distance? The x value, right? So if I wanted to adjust by a measure of 5, what could negative 22 become? What's 5 units to the left? What's 5 units to the right? Help me out. Anyone want to add in the chat box from home? Go for it. You have an idea for me, Ava?
Negative 27.
I've got a possibility of negative 27, sure. And we've got someone from home. Thanks, Nicholas and Dominic. Yeah, what's the other direction now? Negative 17, Ryan is suggesting. What do you guys think about that?
Yeah.
Yep, negative 17. Good job. All right, one more section. Let's turn the page to 165. 165, please. I'm just kind of crunching these all together because I think they belong together and you're ready to hear them together. We did a lot of work already at the beginning of the school year here about coordinate planes. So one step farther is plotting multiple points on the same coordinate plane and creating what's called polygons, right? What are polygons? Shapes, right? That have, they're closed, they have straight edges, they have angles, they have vertex points, vertices. So this is the last piece, is plotting specific points to create polygons. We're doing 165 together right now. Everyone's on 165. So I'm going to be checking over the next couple days that all of these exercises we've done together, plus the ones you're responsible for independently, are completed. So we have classwork and we have homework. Classwork must be completed as well as homework. So we're doing 165 right now together. We have 4 points to plot, and they're going to create a shape. We're going to have to name that shape and then describe lengths of the sides. We can use an approach like by counting the units or combining their absolute values. And then lastly, we're going to look at perimeter. Do you remember what perimeter means? What's a perimeter mean? Perimeter, there's kind of 2 measurements that you got comfortable with, I think in around 3rd grade. There's one measurement that describes the coverage of that space. And there's one measurement that describes the distance around that shape. What is perimeter? What do you think, everybody? Distance around, right? Perimeter. And whenever I say perimeter, I find myself doing this with my hands, perimeter. And it helps me remember that perimeter is what? Distance around. And what's the other measurement? The one that's coverage. Area. Good job. Yeah, the area is a coverage measurement. We're just looking at perimeter today. All right. Plot the points on this polygon. Go for it. Let's plot them. See if I can get a stamp here. Negative 3.5, positive 2, boop, positive 4, and then up 2, positive 4, negative 2.5, so farther than 2, I have to go to 2.5, and then negative 3.5 down 2.5. Okay. Connect those dots for me. And what is a name that you could give this polygon? What's one name you could give it? Okay. Some people are saying rectangle. I'm glad we don't have to go over that. If you said quadrilateral, would you be wrong?
No.
What's the definition of a quadrilateral? No, it's not. A quadrilateral is any 4-sided shape that is closed with straight segments. So there's lots of quadrilaterals. Trapezoids, squares, rectangles, rhombus, parallelogram. Those are all quadrilaterals. Why? Because they have 4 sides. It's closed shape. They have 4 segments connecting each other. But a rectangle is the most specific name you can give this shape. Because a rectangle means a couple of things. It means it's a quadrilateral. It means it has 2 sets of parallel sides. It has 2 sets of congruent sides. So a rectangle is the most specific name you can give this particular shape. Does that make sense? So your first reaction might have been rectangle, but know why. Know why we're saying rectangle. So write rectangle on the line. And what is the length, it says, of the shorter side? So we can count units, we can combine their absolute values, but either way, it looks like this distance right from here to here is 1. So you're kind of skipping 2 little unit blocks to represent 1. That would be 2. That would be 3. That would be 4.5, right? So 4.5 units is going to be for the shorter side. What about for that longer side? This is going to be 1, 2. Make sure you're going by 2 unit blocks here, 2 unit jumps. 3, 4, 5, 6, 7.5. Do you see 7.5? Do you agree?
Yes.
7.5. So I'm going to put 7.5 units. So how do we calculate the perimeter? Do we have to really count all the way around, or is there sort of like a formula you could come up with to make this faster? What do you think, Luke? Oh, that's area. Yeah, length times width is area. What could you do to calculate the perimeter a little more quickly? Do you remember, Ava?
It said that you can count the squares that was on the one side of the line, and then count the other side of the line, see how many's there, and then add them up.
So add them up. So if I added 4.5 plus 7.5, I would only get halfway around that square though, or that rectangle.
Oh,
Then what do I do? Multiply times what?
2.
Times 2. Or I could say 7.5 plus 4.5 plus 7.5 plus 4.5. You can do it that way too, repeated addition. Either way, give me a perimeter. 24? 24 units? Well done. So for the rest of class today and tomorrow, you're going to be independently working on 160, 164, 166. Now, if you only get one of them done today, that's fine. I would start with 160 because it deals with the basics of plotting points. We did some of it together. 160. Then for class time tomorrow, there's no Zoom, but we're going to have some independent work time where you get some time to work on 164 and 166 on your own. Good? All right. Rest of class period. You've got it. Any other questions from home? James, were you able to?
What are the homework pages again?
They're listed on the Google Classroom, okay? 160 is for you today. And the other 2 are for tomorrow. But if you want to you have a little extra time, you can get them done today. Those are going to be 164 and 166.
Are we doing it right about?
Yes, you can check it out on the Google Classroom just for help on remembering what to do there. James, were you able to pull up the Sadlier Connect workbook page?
I think I got my books yesterday. I don't know if I had my workbook. But yes.
Okay, so have you been following along during class?
Yes.
So you have your workbook.
Yeah.
You don't
Sorry,
sound
just
sure. So if you don't have your workbook, you're going to have to go on to Sadlier Connect and go back and do the problems that you should have written down during class. It wasn't just something for you to watch. You were supposed to be doing them while we were doing them. So log on to Sadlier Connect. It's the first 5 letters of your last name and then the first 2 letters of your first name. Password's going to be DC 2020. It's in your planner, but just in case you can't find that right away. All right, kiddos, everyone else all right? Thank you for turning your tests in on time. That was nice. I didn't have to hunt anyone down yesterday. Thank you. All right, have a great rest of your day.
Bye.